Hello everyone, welcome back to our YouTube channel Gurmantra Shiksha Ka Granth. I am your educator Nidhi Dua and I warmly welcomes you at our YouTube channel. So guys, I hope you all are doing good, you all are fit and fine and your studies are going in a smooth manner. In previous lecture, we have studied about electrochemistry and in today's lecture, we are going to study about the electrolytic conductance. So without any further delay, let's begin our today's topic. So guys, in chemistry, electrolytic conductor or simply electrolyte is a conducting medium in which the flow of current is accompanied by the movement of matter. And that movement is in the form of ions. Or you can say any substance that dissociates into ions when dissolved in a suitable medium or melted, thus forms a conductor of electricity. So now we are going to study about some terms related to that conductance, or you can say related to that electrolytic conductance. Number one term is resistance. When you talk about the resistance is denoted by a symbol that is capital R. Metallic and electrolytic conductors obeys Ohm's law, according to which resistance of a conductor is the ratio of the applied potential difference V to the current flowing. And also resistance is a measure of a position of current flow in an electric circuit. Resistance is always measured in terms of ohms, symbolized by a Greek letter that is omega. And now as you can see here, R is equals to VI from the definition. This is very important to note that metallic and electrolytic conductors always obeys Ohm's law. And from Ohm's law, it is crystal clear that R is equals to VI. This is the formula to find out the resistance of a particular matter or a particular substance. Second term is conductance. Conductance is always denoted by a symbol that is C. Capital C. The degree to which an object conducts electricity calculated as the ratio of the current which the flows to the potential difference present. That's why conductance of a conductor is always equals to the reciprocal of resistance. That is, capital C is equals to 1 by R. I repeat, conductance means the degree to which an object conducts electricity, calculated as the ratio of the current which flows to the potential difference. Simply, you can memorize this, that C is equals to 1 by R. And C is always expressed in the Ohm inverse. The unit of conductance is Ohm inverse. Next is specific resistance. When you talk about the specific resistance is always denoted by a symbol that is rho. And now the resistance R of a conductor of uniform cross-section area is directly proportional to its length L and always inversely proportional to its area of cross-section. So from this definition, you may conclude that R is directly proportional to L and inversely proportional to A. When you remove this proportionality symbol, you will put a new constant here that is denoted by rho. And this rho is your specific resistance. That's why the formula becomes R is equals to rho L upon A. If you want to calculate the specific resistance, you can simply interchange the values, and after interchanging the values you will get rho is equals to RA divided by L. When you talk about the unit of specific resistance, that is ohm centimeter. Okay. Next is the specific conductance. If we talk about the specific conductance is denoted by a symbol that is kappa or small k. It is defined as the reciprocal of specific resistance. Specific conductance is reciprocal of specific resistance, that is K is equals to 1 upon rho. This above definition of specific conductance, that this is the reciprocal of specific resistance, applies to the metallic conductors and electrolytes. Okay. C is equals to A upon rho L, and 1 upon rho is your K as you know it. So A divided by K is equals to CL upon A, where L upon A is your cell constant. Now what is cell constant? Cell constant is denoted by symbol X. It is a fixed quantity for a particular cell, and it is defined as the distance between two parallel electrodes of a cell divided by the area of electrodes. So cell constant is equals to the distance between two parallel electrodes, or you can say length, divided by area. This is your cell constant. If you interrelate the cell constant with K, you will get a relation as cell constant X is equals to K by C, and 1 by C is equals to R. That's why cell constant is equals to K by R. This slide is very important because from this slides numerical aspect of question will be formed. From these 2 points question could be asked. Next term is equivalent conductance. This equivalent conductance is denoted by lambda EQ. This lambda EQ is defined as the product of specific conductance K and the volume. And you have to remember that the volume should be in milliliters of the solution which contains 1 gram equivalent of the electrolytes. So lambda EQ is equals to K into 1000 divided by C. What is C? C is your concentration of the solution. The unit of equivalent conductance is ohm inverse centimeter square. Next term is molar conductance. Molar conductance is denoted by a symbol lambda m or mu. You have to remember this. Molar conductance is denoted by mu. This is defined as the product of specific conductance and the volume in which contains 1 mole of electrolyte. Lambda m or mu is equals to K into V. And as you know, what is V? V is volume, that should be in milliliter. So lambda m is equals to K into 1000 upon m, and m is the concentration of solution. Now the factors influencing the conductivity of electrolytes. There are many factors that influences the conductivity. Okay, one by one we are going to study about them. Number 1 is the interionic attraction. If the interionic attraction between solute particles present in the solution is more, then the conductivity will be less. This is very important point. If you increases the attraction between solute particles, then the concentration becomes more, then the conductivity becomes less. Second factor is the polarity of solvent. If the solvent is greater polarized, then the ionization power and the conductivity will be more. Third point is the viscosity of medium. If you increases the viscosity or you increases the amount of solute particle in the solution, then the conductivity decreases. Okay. If you increasing the viscosity of medium, the conductivity will decreases. Next factor is temperature. This is very important factor influencing the conductivity of electrolyte. As you increases the temperature of electrolyte, this conductivity increases. Why this conductivity increases? Because on increasing the temperature, the kinetic energy of ions also increases, and all the type of attraction force decreases, and if all the attraction force decreases, then the viscosity of the medium also decreases. So this is very important point influencing the conductivity of electrolyte, that is temperature. If you increases the temperature, then the conductivity of the solution will increases. Next point is the dilution. The degree of ionization increases with the increment of dilution. If you increases the degree of ionization, then if you increases the dilution point, then the conductivity increases. Why this conductivity increases? Because on dilution the number of ions also increases. Effect of dilution on specific conductance. This is very important point. The point says specific conductance decreases with the increase in dilution. If you talk about the simple dilution, then the conductivity of solution increases on dilution. But if you specifically talk about the specific conductance, then on dilution the conductivity will decreases. So this is very important point. Next is effect of temperature and pressure. Conductivity of all electrolytes increases with increase in temperature. As you have seen in the earlier slide, conductivity of solution is slightly changed with the change in viscosity of medium. The viscosity of dilute solution decreases with increase in pressure. That is, equivalent conductivity increases. If you increases the pressure, then the viscosity of dilute solution decreases and ultimately conductivity will increases. So this is also very important point based on the pressure. So these were some points related to the factors influencing the conductivity of an electrolyte. Now there is a practice question based on the formulas which we have studied. The question says the resistance of one normal solution of salt is 50 ohm. Resistance is given, that is 50 ohm, and you have given the concentration of solution, that is 1 normal. What you have to calculate? Calculate the equivalent conductance of the solution. You have to calculate the equivalent conductance. If two platinum electrodes in the solution are 2.1 centimeter apart, means length is given 2.1 centimeter and area is 4.2 centimeter square. You have to calculate the equivalent conductance. So let's see the solution for this question. As you know, lambda EQ is equals to K into 1000 upon N, or you can say M, that is your concentration. But in question, we have not given the value of K, but we have given the value of rho, that is, we have given the value of resistance. So from the value of resistance, we can simply calculate the value of K. So by the formula, we have calculated the value of K, and after putting the value of K in the formula of lambda M, we get the answer as 10. Okay, so this was the solution for the question. Next question is, which of the following have maximum molar conductivity? You have given two questions. In this one question, you have to find the maximum molar conductivity. Number one is 0.08 molar solution, and its specific conductivity is 2 into 10 to the power minus 2 ohm inverse. Second is 0.1 molar solution, and its resistivity is 50 ohm centimeter. So let's see the solution for this question. For first question, we have solved lambda M is equals to K into 1000 upon M. M is your conductivity, M is your concentration. When you put up the value of K, we have given the specific conductivity, that is 2 into 10 to the power minus 2. So 2 into 10 to the power minus 2 into 1000 divided by the concentration, that is 0.08. After solving this equation, you will get the lambda M as 250 ohm inverse centimeter square mole inverse. While in case of second, we have given the resistivity. But what we need? We need the value of K. So as you know, K is equals to 1 upon rho. Lambda m is equals to k into 1000 upon m. We have put it the value, that is 1 upon 50 into 1000 divided by 0.1. After solving this, you will get the answer as 200 ohm inverse centimeter square mole inverse. As you can see here, in solution 1, the value of lambda m is maximum, that is 250. In case of solution second, that is 200 ohm. That's why, so molar concentration of 0.08 molar solution will be greater than the 0.1 solution. So the correct option for this question would be option number A. That is 0.08 molar solution having the specific conductivity 2 into 10 to the power minus 2 ohm inverse. So this was all about today's lecture. Now, in case if you are new here at our YouTube channel, please do like, share and subscribe. You can also join our Telegram channel for more new updates related to your exam. And if you have any query, you can mail us on tanejanehaofficial@gmail.com or you can contact us on the given number. Now, a very important announcement. If you are preparing for CSIR UGC NET, you can follow Neha Taneja ma'am on Unacademy platform. On Unacademy, you will get daily live classes, structural courses, live test and quizzes, and with one subscription, you will get unlimited access. If you are interested, you can go through with this detailed paid classes. After taking these detailed paid classes, you can use referral code NEHA, that is NEHA, and after using this referral code, you will get 10% discount on total fee. Thank you very much guys. I hope you liked the video.